Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about the standard normal curve. All right, so the standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. It's important to use this standard normal distribution so that you can kind of compare things that don't have the same means or the same standard deviations. So it allows us to compare values from normal distributions with different values using their z-scores. It also makes finding probabilities for normal distributions easier. All right, since we will be finding area under a curve, you could do this by calculus by taking the integral of a normal curve function, which looks like this here. And then if you wanted the simplest version of this formula is when your mean is 0 and your standard deviation is 1, which gives you this other function. But instead of calculus, we convert to a z-score, and we use tables where somebody has already done the calculus for us. All right, so here are two normal curves. This first normal curve is using a mean and a standard deviation, where the mean is mu, some value, and the standard deviation is sigma, some other value. All right, and then that area that's shaded, it's the exact same amount of area shaded on the other curve, except for the other one is standardized. So we went and we actually calculated like z-scores. The z-score is the individual x value minus the mean divided by the standard deviation. Okay, so these are actually equivalent kind of graphs representing the same thing, the same data, except for one has been standardized to have a mean of 0 and a standard deviation of 1. All right, what is the difference between the two normal curves? Explain how the graphs change as a result of the difference. So I have graph A, and then I have graph B. And it also tells me the summary statistics for each graph. So for graph A, my mean is 2, and my standard deviation is 1. And graph B, my mean is also 2, but my standard deviation is 0.25. So the standard deviation of graph B is smaller than the standard deviation in graph A, which makes graph B narrower and taller. All right, go Seahawks.